Just checking. Okay, sulfur analogs. Sulfur is in the same group in the periodic table that oxygen is. If we look at the periodic table on the wall, we see oxygen and sulfur are in group 16 or group 6A. They both have 6 valence electrons, and they're going to behave similarly in compounds. So an alcohol has a hydroxyl group, which is oxygen hydrogen, and a thiol has a sulfur in there instead. And so this is called a sulfhydryl group. It's kind of a funny word. But the sulfhydryl group is this SH. So here's the alcohol. It's got an OH, a hydroxyl group, and thiols have sulfhydryl groups. So they're a lot like the alcohols, but we've just subbed in oxygen's sister, sulfur. These are going to have a lower boiling point because a thiol with a sulfur in there cannot undergo any hydrogen bonding because you have to have oxygen, fluorine, or nitrogen for hydrogen bonding. So no hydrogen bonding with the thiols. Lower boiling point. Thiols, almost all of them have a very strong and very disagreeable odor. They stink. Okay. Natural gas, like the gas we have in the jets here for our Bunsen burners, has an odor, right? That odor is not the odor of methane. Methane doesn't have an odor. Methane is natural gas. But you don't really want flammable gases that you can't detect without equipment floating around in your room. And so they add thiol compounds to natural gas to make it smell. So that when there's a gas leak, your nose alerts you, hey, something's not right. Okay, and that's probably saved countless lives since they started doing that. They just have to add a little bit of thiols to the methane in order for you to be able to detect it because they're very strong disagreeable odors. Another name for thiols, this older name, is mercaptan. And this looks like I had a brain fart when I was making slides. We'll just skip that one and go on to nomenclature. So these are named in using the same pattern as alcohols. With alcohols, we change the ending of the name to ol, and here we're going to change it to thiol to indicate that there's sulfur. So this is butanol, and this is butane thiol. So the E gets left in there for pronunciation's sake, just like we did with the diols and triols. If we had 2 oxygens, it would be butane diol, and so with the thiol, it's butane thiol. Common names use the base name mercaptan instead of alcohol. If this was OH, this would be ethyl alcohol, but it's a thiol, so it's ethyl mercaptan. And this is isopropyl mercaptan. If this was an O, it would be isopropyl alcohol. So swap thiol for ol and mercaptan for alcohol. So convert each of these common names for thiols to IUPAC names or vice versa. If it's the IUPAC name, convert it to the common name. So methyl mercaptan. Remember that mercaptans are like alcohols. What would methyl alcohol be? It'd be an OH with methyl on it, right? So that would be methyl alcohol. So we'll just take this oxygen out and put in a sulfur, and that is methyl mercaptan. So what should the name of that be? The IUPAC name. Well, if it was the O, it would be methanol, right? Right? You guys awake? It's Monday, but it is Monday afternoon. So this would be methane thiol. That's the IUPAC name, methane thiol, because this is methane with the thiol group on it. Sec-butyl mercaptan. Now this is a very old common name. Well, butyl, mom eats pickled bananas, 4 carbons, right? What does the sec mean in sec-butyl? Secondary? There's primary, secondary, and tertiary. That's telling us where the thiol group is attached. If it was butyl mercaptan, then the thiol group would be on the end. But it's sec-butyl, meaning that is attached on a secondary carbon. So it's got to be one of these guys in the middle. Either one is going to be the same, isn't it? So sec-butyl, so this would have, no, not 3, 2. And this would be 3. And this would be CH3. And this one has 1, 2, 3 already attached, so it's going to have 1 hydrogen. Sometimes it's helpful to actually draw the structures and then name them. So sec-butyl mercaptan, as an alcohol, well, let's think of this as an alcohol. If we were naming this as an alcohol, what would we name it? We're looking for the longest chain, longest carbon chain, right, is butane. So that would be butanol, and then we would indicate where the ol is attached with a number. So that would be 2-butanol. But it's a thiol, so it's 2-butane thiol. Being aware of patterns can save you a lot of memorizing in organic chemistry. So you'll learn the alcohols, which we'll run into a lot more, and then you remember, oh, the thiols are just a little tweak of the alcohols. They've got an S instead of an O. Instead of ol at the end, we do thiol. For the common name, instead of alcohol, it's called a mercaptan. I have no idea why it's called mercaptan. We could probably figure that out, but we're not going to. Mercaptan is the common name. So this question is asking us if you're given the common name, write the IUPAC name. If you're given the IUPAC name, write the common name. Any questions? 2 more. So these names, just looking at them real quick, are these common or IUPAC names? These are IUPAC names. So I think it's helpful going back, if you're trying to go back and forth between these 2 names, to actually draw the structure. It's good practice anyway. So 2-methyl, 2-propane thiol. Well, propane is the main chain. So let's draw that first. I'm going to do this one with lines. So I'm going to count 1, 2, 3. Because propane, mom eats pickles. So 3 carbons. And 2-methyl means that there's a methyl group on the second carbon. And 2-propane thiol means on that second carbon is the thiol group. And that almost looks like a chicken claw or something, doesn't it? So that would be CH3, C, with a methyl group and a thiol group, and CH3 over here. Now, if we're trying to do the common name for this, it's something mercaptan. We need the name of this as a functional group. Remember the name of that? I think it's called tertiary butyl, and also, no, that's it, isn't it? It's tertiary butyl. Let me double check. So this group right here has the name tertiary butyl, tert-butyl, T-butyl, one of those. That's its common name. And so then the name of this would be tert-butyl mercaptan. Does that make sense? If you haven't made some flashcards yet, I highly encourage you to do so. Index cards are really, really cheap. You keep them in your pocket. You're waiting for the instructor to open the door, and you flip through a little. You get stuck in a traffic light, you flip through. Commercial comes on during your TV show, flip through them. You need to know, what is a tertiary butyl group? What is a secondary butyl group? Isobutyl, isopropyl, those guys. Okay, this last one. 1-pentane thiol. Well, pentane tells us how many carbons? 5, right? 1, 2, 3, 4, 5. 5 carbons, and where is the thiol group attached? On number 1. Well, number 1 could be on either end. Let's put it over here just for fun. Okay, so if we're going to name this as a mercaptan, then the name of this group is what? Pentane becomes pentyl. So this is pentyl mercaptan. Any questions?
Do we have to remember the mercaptan thing?
You have to remember the mercaptan thing. I think you should. Usually in life, though, you can't do everything that you should, right? I should have made invitations for my daughter's birthday party and sent them out 2 weeks in advance. I didn't. We improvised and pulled it off, right? Sometimes you have to cut corners. And so it's good to do that wisely. So I think if you decided, I'm not going to worry about the common names for the thiols, is that going to cause you to fail the class? No. Not one of the more important things. We talk about thiols and how to name them and stuff, but they're not a huge part of the class. Understanding, what halogenation and hydrogenation of alkenes is, that's a lot more important. So it's a good question. Any other questions? Properties of thiols. Because they have a sulfur group instead of an oxygen in there, they're not going to have any hydrogen bonding. So their boiling points are going to be a lot lower than those of alcohols. I would guess they're more like the ethers and the alkanes. They have a very strong disagreeable odor. The scent of skunks, which we all know is very potent and very obnoxious, comes from these 2 thiols. I'm not going to make you memorize these. These are just kind of up here for interest. This one's 3-methyl 1-butane thiol and trans 2-butene 1-thiol. These are thiols, and they smell really, really bad. And they're really hard to get off. If you've ever had a dog that got sprayed, you know that it's really hard to wash that off. Thiols are easily oxidized. Remember we talked about oxidizing ethers? Oxidizing alcohols. And we can also oxidize thiols. So what's going to happen when you oxidize a thiol is you're going to lose the hydrogen from each group, because oxidation is increasing the number of carbon-oxygen bonds or losing hydrogens. And then we end up with what's called a disulfide bond. So we get a disulfide bond in here, and you get 2 hydrogen atoms being given off. And so we have this relationship between thiols and disulfides involving oxidation and reduction. The disulfide bonds, and this is probably the biggest reason we talk about them at all in this class, disulfide bonds are important in protein structure. And when we get to biochemistry and we talk about DNA, disulfide bonds are a big part of the structure of DNA. Disulfide bonds are present in the protein in your hair. And one of the things that happens when you get a permanent is they put chemicals on to break the disulfide bonds. Then they put your hair in a curler or whatever, and then they reestablish the disulfide bonds in that new shape, and then your hair tends to keep that shape. So the disulfide bonds are important for later. Another sulfur analog is one of ethers. So we can have thioethers. And this is like an ether, but an ether would have oxygen here. So we're swapping out the oxygen for a sulfur. So we've got a sulfur bonded to 2 carbons by single bonds. And these follow the same nomenclature as ethers, but we're going to use the word sulfide instead of ether in the common names, and alkyl thiol instead of alkoxy in the IUPAC names. So here is a thioether. It's got 2 methyl groups attached to the sulfur. So it's dimethyl sulfide. If this was an oxygen, it would be dimethyl ether. And the other name is, remember we choose one side to have, I got it right. We would choose one side to have the sulfur group with it, and that becomes the methyl thio group attached to the methane. So this is dimethyl sulfide or methyl thiomethane. So let's just review our ether nomenclature. That would be dimethyl ether or methoxymethane. Remember that? So we take one of the group, put the oxygen with one of the groups. Here they're the same size. And we name that, this is a methyl group, so this is methoxy, and it's attached to methane. So the sulfur analog is methyl thiomethane. This one's got a benzene ring on it, and there's the sulfur of the thioether and the methyl group. So we can name them by the common method. So this is methyl, and the benzene ring has the name phenyl when it's a substituent. So we get methyl phenyl sulfide. Or we see this is the attachment, and that is methyl thio attached to benzene. No number is needed because it's assumed to be at number 1. Let's look at this guy over here. That's a mouthful, isn't it? This one's too big and messy to have a common name. So the base name here, let's try to sort this out, is pentene. So they've numbered this chain for us here. 1, 2, 3, 4, 5, and this is way harder than anything I'll give you on a test. This is pentene. It's got a double bond here. It's numbered in that way so that the alkene group, the double bond, is at number 2. So that's where we get 2-pentene. And then there's a methyl group on 2. So it's 2-methyl, 2-pentene. And then this is ethyl thio. So 4-ethyl thio, 2-methyl, 2-pentene. Now, I am really not sure why they capitalized the M. I think that's a mistake. I'm not sure if the parentheses there are necessary either, but whatever. That's kind of a crazy out there example. The thioethers, like the thiols, are less common and less important, so we're not going to get too hung up on them. Characteristics. Thiols and thioethers both have strong odors. Thiols tend to be more reactive than their alcohol counterparts, And likewise, thioethers are more reactive than ethers. And that's because the carbon-sulfur covalent bond is weaker than a carbon-oxygen bond. Dimethyl sulfide is a gas at room temperature. Ethyl methyl sulfide is a liquid. That's just like a random fact stuck in there. They do exhibit functional group isomerism, like what we talked about with the alcohols and ethers. So here we have same molecular formula, but this one's a thioether and this one is a thiol. The functional groups are different. That's what makes it a functional group isomer. And so here's a summary of what we've talked about in this chapter. With alcohols, their analog thiols, ethers, and their analogs, thioethers. So that's a good summary. There we go.